Extraction of aluminum. Aluminum is one of the very useful metals, way too useful in the modern day, because aluminum has wide uses because of its light texture, because of its less density, because of its resistance to corrosion. Rather, it is rigid to the corrosion because nature has gifted it with a natural coating of what? Al2O3, which is resistant to even acid attack, which is resistant to oxygen, and it is a non-porous coating, and this non-porous coating will not let anything to intervene and react with aluminum, so it is having a natural coat of its own, acting as a resistant to any corrosion, unlike iron which has a porous coat, and iron rusts completely, but here aluminum oxide is resistant to corrosion, shiny, silvery, reflector. So that's why aluminum is used as fuel storage tanks. Aluminum is used in milk storage vans, being cooling basically, because it reflects the sunlight away. Aluminum has huge uses because of its light, because of its less density, high tensile strength, strong metallic bond aluminum, high tensile strength. Aluminum is used widely in aircrafts and vehicles, inside the car engines, and aluminum in cooking utensils because of a very good electrical conductivity. Aluminum is also used in electricity conductor, aluminum cables, okay, and major uses are aluminum is used in aircraft bodies, made the aircrafts lighter and the vehicles lighter, so less of the engine's fuel is needed and lighter engines are needed, so life become quite easier. But aluminum extractions remain a challenge of the 20th century. Reason was aluminum is a reactive metal. Its compound, the most common compound was aluminum oxide. That was basically it is packed with iron oxide as an impurity and stays in the nature as red mud. We call it as bauxite. Now this bauxite, huge ores are there, red mud is there, but it has a huge impurity of iron oxide. Secondly, separation of impurity is also a challenge because we need a purified ore, and purified ore need to be placed in the electrolytic cell. So one step is purification, and the second step was basically it was having very high melting point, and very high melting point means huge fuel usage. So electrolysis was almost impossible. Very little amount was produced, and people used to say a phrase that aluminum things can be found only in king's meal. But somebody during the research has discovered a magical impurity called as cryolite, a mineral Na3AlF6. You need to learn its formula as well, name as well, and its function. Mostly asked in MCQs and questions, that cryolite lowers the melting point, brings it down from 3000 plus to 980, and cryolite basically acts as a solvent, dissolves it. Any option can be right. Cryolite has dissolved it to such an extent at 980, such a lower melting point, it melts, electrolysis become easier, cost become easier, less cost. As a result, aluminum becomes so common. Everywhere we have aluminum windows and stuff, and cooking utensils and packing of the aluminum in the food because of its non-toxic nature, aluminum. First step is, I said, aluminum is present in the bauxite form, the red mud. And since aluminum oxide basically is present in the bauxite form with an impurity iron oxide, because of that it is red in color, it is dissolved in a huge pool at industrial scale, huge pool of caustic soda, and shaken well, stirred well. You know, aluminum oxide is an amphoteric oxide, meaning it can react with an alkali, it can react with an acid. So aluminum oxide, being amphoteric, reacts with caustic soda and turns into a compound called NaAlOH4. And this compound is further heated with sodium aluminate, we call it as, heated with steam, and we get purified Al2O3. Ore purification, often it is of a 2-3 marks question, ore purification of bauxite. Oxide is mixed with caustic soda, shaken well, aluminum oxide being amphoteric, reacts with the NaOH, separates out as NaAlOH4, which is processed with steam to get pure Al2O3, white talcum powder like thing. And iron oxide, being basic oxide, of course will not react with the base and separates out. So you need to memorize, understand this thing basically, that how the ore is purified. If ore is not purified, we can't place it in the expensive electrolytic cell. And look at the electrolytic cell, specially designed for this purpose. It has cathode made up of graphite. It has anodes, suspended anodes, made up of carbon as well, graphite. They are suspended because normally if they get heated up, we can bring them up so they become little, they get little air, they're cooled down to prevent the reaction of oxygen with the carbon, because oxygen is produced at the anode and it eats away carbon slowly. So bringing them back suspended anodes keep it cool. As a result, that process remain less, the reaction of oxygen with anodes. So anodes need to be replaced periodically even then, but at least that period may be longer. Okay, so we have noticed what? Aluminum is not in the nature as pure aluminum. It is present in oxide form, and oxide is wrapped up with iron oxide as well and other impurities and removed by process of ore purification. Al2O3 is mixed with cryolite and then it is placed in the electrolytic cell. A very high voltage current is needed for this, because aluminum ions and oxide ion, aluminum ion need 3 electrons per ion. Huge voltage, 40-50,000 volt. That is why it is said that hydroelectric power is needed for a cheaper, to make process quite feasible. So we are going to see basically what the electrode reactions occurs at cathode and anode. Okay.